Okay, so today we're writing exponential functions. So I'd like us all to look at this handout I gave you, writing exponential functions. And let's just read together, okay? So it says we can write exponential functions of the form, and we'll write down the form um, y equals a times b to the x. This is our standard form for exponential functions. Y equals a times b to the x. To represent graphs or tables by identifying the values of a and b. So our goal for today is we'll be looking at tables and graphs, and we want to identify the values of a and b. Okay? So we're going to use some real-world examples below to explore finding these values. All right. So we'll begin with number one. Okay. Home Run Hats is a startup company that has seen exponential growth in hat production since launching their business. Use the equation and table representing the number of hats produced T, number of hats produced after T number of years to complete A through C. Okay, so we're going to finish A through C here. And we have the hats represented by the variable, the years represented by T, and H of T is going to represent the number of hats. And as you can see, that's grown quite a bit. All right, so how many hats did they produce when the company launched? 1,000. Just 1,000. Okay, and so we want to figure out how can you find the initial number of hats from the equation and table? Well, let's see here. So let's do this. Let's go to our equation. Okay. This number 1,000, which of our variables does it represent? A. Okay. And the 2 is representing B. Okay. So it's pretty obvious, if you look at this, where we get the 1,000 from, right? Now let's figure out how we can come up with maybe that B value of 2. Yeah, it's going to have to do definitely with the number of hats. So obviously for A, it equals H at 0, which was 1,000. Okay. And so that's going to be your A value. It's always going to be whatever is happening at 0. Okay. Let's look at the ratios. So let's see. We want to compare H of 1 to H of 0. How much was H of 1? 2,000. And then we're going to compare that to H of 0, which was 1,000. And that'll obviously be 2. And then let's just do the continue. We're going to do H of 2 to H of 1, so that'll be 2,000. I'm sorry, 4,000 to 2,000. Put that away. Put it completely somewhere where it's not seen, not in your hands. Thank you. Okay. We'll do 8,000 to 4,000. Oh, by the way, that was 2. That was 2. And the last one, does that give us 2? Yeah, because it's 16,000 to 8,000, which is 2. Okay. So I think we found how B is determined. Where do you see the ratio found in part C in H of T? Obviously here. Okay. So the ratio of, we're going to say H of n minus n plus 1 to H of n H of n plus 1 to H of n. So the one that came after to the one that the current one is going to represent your B value. In this case, 2. So basically, it's the B value of the equation. And that's basically what we need to write our equation. So basically, for exponential functions of the form y equals a times b to the x, we call the, put it on silent, please, or vibrate. The value of b is called, we call this the common ratio. We're going to start calling this the common ratio. And as long as you know that it's a table of exponential values, you pick any two of your values and create a ratio, and that's going to be your b value. Okay. The y value of the function will grow by a common factor of b as the x value increases by 1. Label the parts of the exponential function in the box shown below. Okay. So remember what we called the a value? This was our initial value. So this is our initial value. And what did we just learn the name for the b value is? The common ratio. So that's going to be our common ratio. So a is the initial value. Write this down. Jaime, write this down. It's going to be, if you see it in the test and you didn't take it in the notes, then I don't know what to tell you. And basically, it's the y value when x equals 0. It's the y value when x equals 0. B is the common ratio. And can be found by dividing y values. y values of corresponding consecutive x values. That's important. They have to be consecutive, one right after the other. So you can't just pick any two. They have to be back to back. Okay? Any questions? So we've labeled these. A is the initial value. B is the common ratio. And this is how we find them. Okay, so for 2 and 3, we're going to find the values of A and B, and then we're going to write the equation to represent this exponential function. All right? So let's see how easy this is. Starting with, how do we find the A value? Look at 0. Mainly, it's going to be 14. Look at the y value when x is 0. Okay? Now, to get the common ratio, or B, pick any two consecutive y values. So which ones do you want to pick? Probably 0 and 1. I mean, we could deal with, we've got calculators, but, well, which one goes on top, though?
1.
Well, we want the y values, though.
7.
7 goes first. 7 goes first. 14 goes second. Okay? And we end up with 1/2. So now we can put it all together. We want this equation, y equals a times b to the x. So in our case, it would be y equals, well, instead of a, we're going to put 14 times 1 over 2 to the x. There it is. Okay? So go ahead and try number 3. Go ahead and do number 3 the same way. Figure out the a, the b, and then write your equation. Okay? And if it is a fraction, reduce it to lowest terms. Probably not a good idea. Decimal's okay. Okay, if you did this correctly, you should have something like the a value is 9, and I set up the ratio 12 over 9, and that gave me 4/3, and I just left it as 4/3. If you did 1.3 repeating, that would be fine as well. So I got y equals 9 times 4/3 to the x. All right, guys. Let's move on to number 4. You guys ready? All right, let's take a look. So it tells us that a similar method can be applied to write exponential functions from a graph. Use the example to determine the values of a and b from the graph. The graph shows the exponential function g of x. So this is g of x. What is the value of a, and where can we find it? What is it? 5. Yeah. The a value is 5, basically because the coordinates are 0, 5. So we remember we want the y value when x equals 0. So we were looking for basically g of 0, which equals 5. Okay. Then it says list 2 coordinates points that could be used to find the value of b by setting up a ratio. What must be true about the x values of these points? Yes.
They must be like one after the other.
One after the other. Like we could use the first one, right? So we can use 0, 5, but if we use that one, we have to use this one, 1, or the one before. Well, they have to be consecutive. If I'm using this one, I have to use 1, 15. So basically the x values have to be consecutive. X values must be consecutive. That's the catch. So now let's find the value of b. Basically, we're going to set up the ratio. Which number is our numerator?
15.
Yeah. 15 goes on top, and 5 has to go on the bottom. So basically it's, what, 3? So now we can write our equation. Y equals, times 3 to the x. 5 times 3 to the x. There it is. From a graph. Okay. So we're going to practice this a little. As you can see, it's not very hard. Just have to know how to read the graphs. All right, let's start with our a value. 20. So it's 20. Now pick a couple of numbers. I think I'm going to pick 0, 20. And what's the value at 1? 110 then. I'm going to pick those two values. 10 over 20. B is going to be 10 over 20, which is 1 over 2. So our equation is y equals 20 times 1 over 2 to the x. Or you can put 0.5 to the x. Okay, go ahead and try the next one on your own. I got 5 halves as a decimal, 2.5. Now if you would have done it, y equals 10 times 5 halves to the x, that'll work too. All right, so answer question 7 and 8 based on what we've learned so far. Uh-huh. Yeah. So I think she did maybe something like 9 over 36, which would have given her 1/4, when it should have been 36 over 9, which is 4, which is a correct common ratio. All right. Which one is the correct equation for number 8? Yes, go tell us.
Equals 6 times 3x.
Yeah, Thomas.
Or y. That's on 4,
Yeah.
Oh, yeah,
3. I know what you meant. And it is Thomas. All right, guys. So basically, this is going to be it.